Hi guys, welcome back to A Case of Econ Struggles. Welcome to another macro struggle. Today we're going to talk about the Fisher model. The Fisher model is a very advanced new Keynesian model of price setting, and it's going to be a lot of math. So we're going to go through it slowly. We're going to set it up, and then I'm just kind of walk you through the derivation. Timestamps are below if you would like to jump around, but feel free to pause as we go and re-watch sections if it's not clear. The setup of the Fisher model, we're going to say there's two firms in this world. One is owned by Bill, one is owned by Dave. Bill's firm was established in January of 2000. Dave's firm was established in July of 2000, so 6 months apart. Both Bill and Dave have to set prices 12 months at a time, and the prices can't change within those 12 months. So when Bill sets his prices in January of 2000, he's setting for both the first half of 2000 and the second half of 2000. Dave, when he comes on the market in July 2000, he gets to set the price for the second half of 2000 and the first half of 2001. So let's just make that a little more clear. So here's the first couple years of price setting. We can see that Bill sets his prices in January of 2000 for all of 2000. And then in July of 2000, Dave gets to set prices for the second half of 2000, and that persists into the first half of 2001. In the first half of 2001, Bill gets to set a new price for all of 2001. Then Dave gets to set the price for the second half of 2001 and the first half of 2002. We just go back and forth, back and forth, back and forth for all time. Now, what is the price level in any given period? Well, the price level is just the average of Bill's price and Dave's price, where Bill has set the price today and Dave set the price 6 months ago if we're talking about the first half of the year, and the opposite if we are in the second half of the year, where Bill set his price last period in the first half of the year, and Dave is setting his price now for the second half of the year. Now, let's also think about some other equations we have available to us. We know from the GDP that Y is equal to real money supply. I could take the log of that equation and say the log of Y is the log of M minus the log of P, where M is the money supply and P is the price level. All right, I can just write that in lowercase letters because maybe I'm kind of lazy and econ people tend to do this all the time. Now, Y equals M minus P. Again, those are logs, but we say that prices are sticky. A big thing of new Keynesian economics is prices are sticky. So we introduce this real rigidity equation where the optimal price minus the actual price level is some value phi times Y, where phi is the real rigidity parameter. Now, this is what we call the real rigidity equation here in pink. We will talk about the real rigidity equation more in a separate video, but here is the equation for now. Now I can combine this blue equation and this pink equation to make the green equation, where all I've done is substitute that Y equals M minus P in for Y in the pink equation. And I get that the optimal price for either Bill or Dave is just the real rigidity parameter times the money supply plus 1 minus the real rigidity parameter times the price level. Again, both of those are in logs. Now here again is the average price or the price in any period T. It's half of Bill's price plus half of Dave's price because there are only two firms. All right, well, I'm going to do is I'm just going to plug that PI star equation in for PBT and PTD. Notice that for Bill, we know that he knows everything that's going on. He's setting the price today, but Dave does not. Dave had to set that price 6 months ago. So the best that Dave could do is forecast or predict what he thought the money supply and the price level will be 6 months from then. So that's the expected value of T minus 1 of that same equation. And again, all Dave is doing is taking those expectations. Basically, Bill is also taking an expectation, but we're going to assume rational expectation, which means that my expected value of the temperature today, if I'm forecasting today, well, I just open my phone, I look at the actual temperature, and so my predicted value is just whatever the actual value is. So I don't need to include expectation if my forecast period and the period I'm trying to forecast are the same. Now, let's think about the strategy for solving. First, I'm going to solve for Bill's optimal price level. Then I'm going to think about what Dave expects Bill's optimal price level to be. I'm going to use that to find Dave's optimal price level in any given period. And I'm going to use both of those to find the overall price level, the overall output, and we're going to interpret it. Now, like I said before, there are lots of math going on here. I'm going to kind of walk us through it. Feel free to pause, write notes, think about the derivation on your own as you need to. Again, tons of math, but I'm going to try to make this as painless as possible. So first, I'm going to think about this optimal price for Bill, which we know is this guy. And I'm going to think about what Bill thought it was going to be last period. And again, I'm just going to include the fact that the overall price level is the average of Bill's optimal price and Dave's optimal price. Okay, I can plug this overall price level in here. And then I get to this equation right here. Again, all I've done is plug in the average price for that price level. Then I'm just going to multiply out that equation. Okay, well, I don't need to expect that my optimal price tomorrow because I get to set it. I don't know what the money supply could be tomorrow. I don't know what Dave will do tomorrow. So those are both expectations. But this guy I definitely know, so I can take that out. And then I'm just going to do some algebra and kind of work on it a little bit. And I'm going to solve for PTB star. So I have a PTB star here that I can bring over. And then I can just simplify this fraction to 1 plus phi over 2 right here, and then divide or multiply by 2 over 1 plus theta. And I get to this equation here. Cancel these 2's, and now I have Bill's optimal price. Okay, so now I know that Dave is setting one price before Bill sets his price. So that means that he needs to think about what Bill is going to do one period before that in period t minus 2. So now we're going to think about what is the expected value 2 periods ago of Bill's optimal price today. Well, I'm just going to plug Bill's optimal price in with expectation, which is just this purple line. Notice that I have an ET minus 2 of ET minus 1 of MT. Well, my best forecast 2 days ago of my best forecast yesterday of the temperature today is really just my best guess 2 days ago of my temperature today. If I predicted myself to be wrong, I'm not a best guess. So I can really just take out this ET minus 1 and keep this E minus 2. So now I have that the expected value 2 periods ago of Bill's optimal price today is just going to be this guy right here after a little bit of algebraic manipulation. Why did I take the expectation 2 periods ago of Bill's price today? Because that's going to appear in Dave's optimal price. So Dave's optimal price is going to be the expected value 2 periods ago of the money supply and the price level today. So I'm once again going to put the fact that PT is the average of Dave's price and Bill's price. So I've just plugged that in right here already, kind of substituted it in and multiplied that 1 minus theta and the 1/2. So now I can just expand that a little bit. And here is the expected value 2 periods ago of Bill's optimal price today. Now we're at a place where the fractions are going to get kind of complicated. So I just did some work off to the side. Here's Dave's optimal price. Again, we're really just doing algebra here. So this fraction right here is this work right here. Now we've gotten this even worse fraction, and I'm just going to keep simplifying. It's going to be a lot, but I keep going, I keep going, I keep going. And it all cancels out to the fact that Dave's optimal price today is just whatever he expected the money supply to be today 2 periods ago. So now that I know that Dave's optimal price today is just his expected value of the money supply today from 2 periods ago, well, I also know that Dave's optimal price appeared in my optimal price for Bill, because Bill is going to think about what Dave does when Bill sets his price. So now I can just plug in Dave's optimal price into Bill's optimal price function. And now Bill's optimal price function is just a function of MT, and it no longer includes Dave's optimal price. All right, well, I'm just going to go ahead now and split this up because this looks kind of weird. I really would just like one fraction. I know that 1 minus phi over 1 plus phi is just 1 minus 2 phi over 1 plus phi. So I can just plug this in like this, and then I get E times minus 2 of MT plus all this crap. Now I have the optimal price for Bill. I have the optimal price for Dave. I know that the price level overall is just the simple average of those two. I'm going to plug them in. And now I can see that the price level is just this large monster right here. Notice that the 1/2 canceled the 2 right here. That's why you have phi over 1 plus phi. I also know that y is mt minus pt, and this is the gross function for pt. I just can plug that in. I simplify it a little bit, and I get yt is this ridiculous thing here. And now we're done. So we have solved for the price level. We have solved for the overall output. We've solved for Dave's optimal price. We've solved for Bill's optimal price, and we are done. Super complicated mathematically, but hopefully this gives you a better sense of how to go through and derive the Fisher model. If it was helpful, make sure to like and subscribe. If you're still confused, make sure to comment below, and we will see you next time for another case of econ struggles.